morning. Today I'm going to continue with the method of completing the square when a doesn't equal 1. But before I start, I want to thank Emma for her question, and I will start by answering Emma's question. It was question 2 from the homework, and it says, find the value for c that will make this quadratic a perfect square. We know that if a quadratic a perfect square, we must have three conditions. A must be a perfect square, C must be a perfect square, 2 times square root of A times square root of C has to equal B. So this is what we are going to use to find C. If this is a perfect square, 2 times square root of A times square root of C, which I don't know what is it, will equal B, which is 6. So 2 times square root of A of 1 times square root of C, which what I need to find, equals B, which is 6. Now 2 square root of 1 is 1 times square root of C equals 6. I will start to isolate C. So the first thing I will get rid, 2 times 1 is 2. I will get rid of the 2 by dividing. So square root of C equals 3. I divided both sides by 2. Then to get rid of the square root, I square both sides. So the opposite operation of square is square root is square. So I am going to square both sides. Square root and the square cancels out each other, so I have C equals 9. Okay? So if this is a perfect square, if C is 9, and if you look, you will find that all the conditions are met. A is a perfect square, C is a perfect square, 2 times 1 times 3 equals 6, so this is perfect square, and we can even factor it like that. Okay, so this is the answer for Emma's question. I will do another question. Let's say x squared minus 80x plus c equal we need to find C that will make that a perfect square. Again, to have this as a perfect square, square root of A times square root of C times 2 has to equal the middle term. Absolute value, even negative 80, we're not going to make a difference. Okay, negative 80, let us see. Okay, to solve, I will substitute 2 times square root of 1 times square root of C equals negative 80. So 2 square root of C equals negative 80. Divide by 2, so square root of C equals negative 40. Then to get rid of the square root, we square both sides. And when we square both sides, the square and the square root cancel out. So C will equal negative 40 times negative 40, which is negative times negative is positive, which is 1600. Okay, so this is a perfect square if it is 1600. Okay, so this is the answer for number 2. I hope that I answered your question, Emma. We are going to start our lesson today, completing the square when A doesn't equal 1. So let's say we have a question that says find the max or the min for y equal 2x squared told you yesterday, when a question say find the max or min, we need which form, the form that give us the max and min is the vertex form, not the standard, not the factor. So this question, saying in another way, put this in vertex form. So the process we have to use to put this in vertex form is called completing the square. It means this is not a perfect square. Somehow we're going to play some math games to make it a perfect square. Okay? So when we did this yesterday, I told you we have to follow certain steps. The first step is put bracket around the first and second term. Group the first and second term. Yesterday A was 1, so we didn't do anything. We didn't do the second step. So now we're going to factor A out. So always factor A out. So in this case, this will be 2x squared plus 6x plus 6x plus 4. Then the third step, we are going to get the number in front of x. So number in front of x. And what we're going to do with it, the same as what we did yesterday. Divided by 2. So 6 divided by 2 is 3. Then we square the 3, and this will be 9. Then what we're going to do with this 9, we are going to add it and subtract it. Between brackets. So we are going to rewrite this 2x squared plus 6x plus 9 minus 9. Note here, I didn't change anything. I just added and subtracted the same number, so this is 0. I didn't change the identity of the term. It is the same, just added and subtracted 9. Now, if you look, these 3 terms will make a perfect square. So I want to take this out. But when A was 1, it was easy. I just took it out. Now, when A is a different number, this is not free to go out. It has to be multiplied by 2. So take the negative value out after multiplying it by A. So what we're going to have is 2x squared plus 6x plus 9. This stay inside. Then we take the negative 9 out, but it's not free. It has to be multiplied by 2. So we're going to have negative 18 minus 4. Now, this is a perfect square, so we factor the perfect square. So square root of the first, sine of the middle, square root of the third, and we put a square here. And we add those 2, we combine like terms, so negative 22. Now, if you look at this, this is a parabola that opens up. So it has a minimum equals negative 22. Okay? This is in the form of a x minus h plus k. So k is negative 22 and h is negative 3. Okay? Now let us say I want to sketch a graph for this parabola. What I'm going to do. First thing, I will plot the vertex. So I have the vertex is at negative 3, negative 22. So I will plot this negative 3 and negative 22. Then I want this will be the axis of symmetry as well. I know that this will cut the y-axis at 4, so I have a point here at positive 4. Let's say positive 4 will be here. And from symmetry, I can know that if this is 0, 4, and this is negative 3, negative 22, so I will have another point at -7 and 4 from the symmetry, and I will graph. Okay, this is one example. I will do one more example. So let us say I give you this quadratic and I ask you to y equal -x squared plus 8x plus -10. So I'm going to follow the steps. First step is group the first and second term. Second step, factor a out. So we factor the -1 out. -1 x squared minus 8x minus 10. Then we take the number in front of the x, doesn't matter, -8 divided by 2, that's -4. Then we square it. Okay, this is the first step, this is the second step, this is the third step. Fourth step is the value we get here in step 3, we're going to add it and subtract it between the brackets. Okay, now we are going to keep the positive value inside and we take the negative value outside. So y equals -x squared minus 8x plus 16. I will take the -16 out. But -16 is not free, it is multiplied with the -1. So we have to multiply the a with the value we are going to take out. So -1 times -16 is +16. Now, the last step is we factor the perfect square. So this is a perfect square, the minus stay, square root of the first, sine of the middle, square root of the third, and we put a square here. We combine like terms, this is 6. Now we know this is a vertex. The vertex is at 4 and 6. Ax minus h plus k. So this is h and this is k. 4 and 6. We know the vertex. And we can sketch a graph for this. This is a minimum because the graph is, so the minimum value is 6 because this opens down. Now let us try to sketch a graph for that. 4 and 6, so the vertex is at 4. Let's say this is 4 and 6 is here. This is 4 and 6. This is the vertex and this is the axis of symmetry. We have a y-intercept at -10, so this is y-intercept at -10. That means we have also another point here which is -8 and 10 because of the symmetry. 8 and 10. 8, 10. Then we can sketch, and as you see, this is the maximum value is this, and this is the maximum point. Okay. It is the same exact thing that we did yesterday, except for we factor a out, and when we take the negative part, we have to multiply it by